I need to change my sound settings. Looks like we're good. My headphones are about to die too. Okay. Pacific Atlantic water flow. How do you do this again? Okay. So basically, here we're going to iterate from the Pacific Ocean side and the Atlantic Ocean side, and we're going to go inwards. And for every value on the border, we're going to make a duplicate grid for both the Pacific and Atlantic Ocean. And if the value directly adjacent to the current one is greater than or equal to the current one, then we will flag those as true for the Pacific Ocean. And we're going to do that for the entire grid, going from this side, the 0 coordinates, to this corner. And then for the Atlantic Ocean, we're going to do the same thing, but for the length coordinates. So everything on this side. And we're going to go from here, this side, to the Pacific Ocean side, and have the same rule. So if any adjacent values are greater than or equal to the current value, then we will mark that as true. And then we're going to iterate throughout the entire grid. And if it's true on the Pacific Ocean and the Atlantic Ocean, we know that at that given point, we can reach both the Pacific and Atlantic Ocean. So yeah, we're going to make our output and then we are going to so for each value, oh wait, actually, we're going to store the rows and the columns. And for each, if we're iterating rows, we're going to hit columns. So for each of these values, these columns, we are going to run DFS. So the row is going to be I, and the column is going to be 0. And then we're going to pass in integer.min value as the current value. I think we have to pass in heights and our new Pacific check, and then Boolean Atlantic check, rows calls. Yep. So we're gonna add these right here. And then we're going to make this a Pacific check. So we're going to run DFS on this column and pass in heights, pass in Pacific check, and pass in the previous value. And we're going to do the same thing for this row right here. So in I equals 0, I has to be less than calls, I plus plus, DFS, 0, I. Heights, Atlantic check, integer.min value. Okay, perfect. And then we're going to iterate through everything. For each of these values, we're going to see if Pacific check for the coordinate and Atlantic check for the coordinate. Then we're going to make a list of integers called coordinates. We're going to take the coordinates and add I, add j, and then add the coordinates to output. And then we return output. And then we are going to make the DFS. So heights int or Boolean visited int prove. So if row is less than 0, or column is less than 0, or row is greater than or equal to heights.length, or call is less than or equal to heights row.length, we're going to return. So if it's out of bounds, if the coordinates are out of bounds, we're going to just suspend execution. Or sorry, terminate execution, not suspend. And then if the current value is greater than, actually no, if the current value is less than or equal to the previous value, we're also going to return. And then if we have visited, we're going to return as well. So now we know that it's on the board, it is a tile that we can flow to, and we haven't visited it yet. So we're going to mark it as visited, and then we are going to travel. So we will go row +1 call. We're going to travel to the adjacents. So heights visited, and then heights row call, and then DFS row -1 call heights visited, heights row call, DFS row call +1 heights visited, heights row call, DFS row call -1 heights visited, heights row call. Okay, then we should be good. Or not. Shoot. We only did Pacific. Oh, wait, sorry. So this needs to be Pacific check. Sorry. So we've done the columns and the rows. And now we need to do, I forgot to do the Atlantic Ocean. So we will run this again in I equals 0. I has to be less than rows I ++. And then DFS I, and then this will be rows -1. and then heights Atlantic check, and then integer.min value. And we're going to do the same thing here. I0, is listing calls, I++, EFS. This is supposed to be calls. Row is -1, I, heights, Atlantic check, integer.min value. Looks like I'm missing one. Don't know why either. Wait, I think it's just less than. Yeah, there we go. Okay. Time complexity. It's pretty bad. Yeah, it's pretty bad. Oops. I don't really know the time complexity here. Java. Let's see. Show me the time complexity. Not found. Time complexity. There's no way. I don't think it's actually that. Let's see. Let's ask. Whatever. What? Can't the DFS theoretically run n times though? Can't. It's gonna hallucinate and just tell me I'm right though. I feel like. Like, how does that work? Oh. So it's just of 3. It's 3 of that basically. Okay. So for this one, we are going to traverse the border like this. And anytime we hit an O, we're going to turn them into like temporary variables, like a B for border. And we're going to do that for each adjacent value as well. And then we're going to iterate through the entire grid and convert all the existing O's into X's. and then all the existing filler or characters into O's. And that's basically it. So we can hit it like this, calculate the rows, calculate the columns, and then you hit DFS on I0. Yeah, wait, is that it? No, board, yeah. And then we keep on doing that. I think we can do like cause -1 board. Yeah, something like that. DFS 0I board, DFS rows -1 I board. And then we're going to iterate through everything. If board ij equals O, we're gonna make board ij equal X. Otherwise, if board ij equals, let's use B, board ij is gonna equal O. And then do we have to return the board? No, we don't. And then we're gonna make DFS, public void DFS in row in call char board. If we're gonna do the make sure the coordinate exists, if board or row call equals X, or board row call equals B, return. Then board row call equals B, and DFS row +1 call board, DFS row -1 call board, DFS row call +1 board, DFS row call -1 board. We should be good. There you go. So this is going to happen in of n, so O of n times m, where n is the amount of rows, n is the amount of columns. It's just like a ton of, yeah. That's interesting. I never thought of it that way. Course schedule. So this is actual like graph stuff, I think. Yeah. Okay. So we're going to make an adjacency list. The way I'm going to do this is make an adjacency list of all the graph, of everything. And then I'm going to find out what has 0 prerequisites. And then I'm going to topologically iterate through, I'm going to use BFS basically. I don't know why I say topologically anymore. Anytime I use a queue, I say topologically. But I'm going to iterate through all those values. What the heck is happening? I need to open Spotify. Oh, it doesn't open? It doesn't pop up for it? Oh, wow. Cool. Yeah, so I'm going to BFS through everything. And I'm only going to add things to the queue if they have 0 remaining prerequisites. So if we, so there'll always be theoretically there should always be a class that has 0 prerequisites, or that we have unlocked. And then I'll return whether or not we have unlocked all the classes yet. And that's basically what I'm doing. So I'm going to make the adjacency list equals new array list. I have to add new array lists. So I need to make enough lists, enough adjacency lists for all the number of courses. And then I need to iterate through the prerequisites to be able to add them to the adjacency lists. So prerequisite mapping, prerequisites, int int prerequisite equals prerequisite mapping 0, and course equals course or prerequisite mapping 1, right? To take course 1, you have to have finished course 0. Oh, no. It's the other way around. 1, 0. So to take course 1, you need to have taken course 0. So the second one, the class at index 1 will be the prerequisite to the class at index 0. So I need to take graph. There's something else I need to do. So I need to be able to store each class's number of prerequisites. So prerequisite count. Use new int num courses. So I don't like how that looks. Let me do this. Yeah, that looks better. So prerequisite count for the course equal or plus basically. And then graph dot get course or prerequisite to add course. We want each value in the graph to point to, basically we're going to iterate through, we want to be able to get, for a given class that we take, we want to be able to get a list of the classes that it unlocks. So for every prerequisite, we're getting each course that it unlocks. Now, if so we're going to iterate through all the prerequisites again. Courses plus. And here we're going to do I think it's gonna store an array. I don't see why it would though. Maybe it's just integer. So we're going to iterate through all the course numbers, and if the prerequisite count for that particular course number, if that equals 0, then we have a class that has no prerequisites. So we are going to add that to the queue, like so. And then while the queue is empty, or is not empty, we're going to grab the course. And then we're going to iterate through each unlocked course from graph.get course. So we're going to take the prerequisite counter for that unlocked course and decrement it. And if that prerequisite count for the unlocked course equals 0, then we're going to offer it to the queue. And then we're going to return what are we returning? Oh. Completed courses equals 0. Completed courses plus plus. So if completed courses equals num courses -1, I think. Maybe it's not -1. Yeah, it's not -1. There we go. Beautiful. Cool. Oh wait, I forgot time complexity and everything. I think that's just O of n or V, or yeah, where all of them are the nodes. It's just the number of nodes, I think. Let me check something. Process all edges. O plus P. So each connection. Yeah. So topological iteration. This takes P, but this takes N. Yeah. Okay. That actually makes sense. This also takes P. All right, one more and then daily challenge time. Hopefully it's easy. This is the same thing. I'm not going to go and explain it, but it's the same thing, except we have an output array of the order that we finish in, basically. See how quickly I can do this. There we go. This is the same thing. Okay, this is perfect timing. It's 6. Daily challenge time. I have like 10 minutes to do this daily challenge. So let's hope it's not hard. Oh my gosh. Give an integer array. Fine. Give an integer in nums, an integer k. Find 3 non-overlapping subarrays of length k with maximum sum, then return them. Subarrays 1, 2, 2, 6, 1, 2, 2, 2, 6, 7, 5. What? 1, 2. Input. Oh. Starts at 3, 0, 1, 2, 3, 2. What does non-overlapping subarray mean? Oh, okay. This is definitely DP, bro. This is definitely DP. I might do this tomorrow because I have to pick someone up. Yeah, okay, I'm gonna... Yeah, okay, I'm gonna end this because this is too long and I don't have enough time to solve it. I think it's probably dynamic programming though. There's no way this is not dynamic programming. You could do like rolling 2s, rolling Ks. Yeah, rolling Ks. It'd be hard. Actually, no, it wouldn't. You do rolling Ks. No, yeah, it would be hard to not overlap. The non-overlapping part makes it hard. Because you could just do rolling Ks, add them up, put it in a priority queue, sort it by index, or sort it by